Hello everyone, here is Nanxian. I am going to talk about the question 4.1 and question 4.2. So let's first come to the question 4.1. For the first question, it tells that the Quality Assurance Department for distilled water company maintains meticulous records on the bottling line for 2-liter distilled water bottles. Records indicate that the process follows normal distribution with a mean amount per bottle of 2.01 liters and a standard deviation of 0.025 liters. Suppose the foreman selects a random sample of 16 bottles and the sample mean is 1.994 liters. Compute the probability that a sample of 16 bottles will have a sample mean of 1.994 liters or more. So here the question tells us that the mean of the population is 2.01 and the standard deviation is 0.025. So we can construct the normal distribution of the liters, which is 2.01, 0.025 squared. And as the question tells us that this process follows normal distribution, assume that X bar be the average amount of the liters of 16 bottles. We can construct the normal distribution of it, which is 2.01, 0.025 squared then over 16, which is the number of the sample. Now we are going to calculate the probability that X bar larger than 1.994. This equals to probability of X bar minus 2.01 over 0.025 over 4 larger and equals 1.994 minus 2.01 over 0.025 over 4. And this equals the probability of V larger than equal than minus 2.56. And then this equals to 1 minus probability of V larger than 2.56 and equals 1 minus 0.00523 equals 0.99477. Okay, let's come to the question 4.2. The question tells us that 25% of students in ABC College would like to major in statistics. Suppose a sample of 100 students is being selected. What is the chance that between 24% and 28% of students in this sample would like to major in statistics? So from the theorem of binomial distribution, we can have the estimation of the p-hat, which equals to the proportion of students who would like to major in statistics is 25%, equals to 0.25. And we can also calculate the sigma of the p-hat, which is square root of p times 1 minus p over n, and equals to square root of 3 over 40, equals to 0.0433. Now let P be the probability of proportion. Let P be the proportion of the student who would like to major in statistics. We can construct a normal distribution, which is 0.25, 0.0433 squared. And now we are going to calculate the probability that P larger than 0.24 and smaller than 0.28. This equals to the probability that x larger than 0.24 minus probability x, is p larger than 0.28. And this can be translated to probability of z larger than 0.24 minus 0.25, which is the mean, and over 0.0433 minus probability that z is larger than 0.28 minus 0.25 over 0.0433. Then this equals to 1 minus probability of z larger than 0.23 minus probability z larger than 0.269. After checking the statistic table, this equals to 1 minus 0.4090 minus 0.2451 equals to 0.3459. That's all. Thank you.
Hello everyone, my name is Fan Chengyun, and now I'm responsible for question 4.3. So now for the first step, let's list out all the information provided in the problem. Here from the question, we can see that the company has a population size of 350, and the sample size is 40, with the sample mean is calculated as 12,000. The population standard deviation is provided as 1,000. And here we want to construct a 95% confidence interval for the population mean. Now for the next step, let's choose the appropriate confidence interval formula for this question. Since we're given the sample size n equals to 40, which is greater than 30, so the sample size is considered to be large, we can use the z-distribution to construct the confidence interval. This is appropriate due to the central limit theorem, which states that the sampling distribution of the sample mean will be approximately normal distributed for large sample sizes, regardless of the population's distribution. Then, to find the 95% confidence interval, the significance level alpha equals to 0.05, with the corresponding z-score equals to 1.96. This can be checked by the normal distribution table in the next page. So z equals to 0.05 equals to 1.96. Finally, now we come to the last step. Let's plug in the values into the confidence interval formula. Here, through calculation, we can get the interval estimate of the population mean. The 95% confidence interval for the population mean is between 11,690 and 12,309. So that's all for question 4.3.
Hello everyone, my name is Zhou Haodi. Now let's look at question 4.4. We will use both J method and the T method to solve this question. The problem provides us with data like the sample size is 68. Sample size is 68. And the sample mean is 252.45. Sample mean 252.45. And the sample standard deviation is 74.5. Now we need to calculate the 95% confidence interval. So we use the Z method first. Because the sample size is 68, larger than 30, so we can use the Z method to calculate confidence interval. Firstly, we find the Z value in the static table. We can find like the 0.025 is 1.96. Secondly, we need to calculate the standard error. We should use the sample standard deviation divide square n. So it's equal to 74.5 divide square 68. Finally, we can calculate the confidence interval. We use the simple mean plus and minus Z value times standard error. So we can get the answer is 234.3811 to 270.5189. Okay, secondly, we will use T method to solve this problem. So, firstly, we need to find the degree of free. We use n-1 to calculate degree of free is 68 minus 1 is 67. Then, according to the static table, we can find the T value. Is 1.996. Then we need to calculate standard error. Standard error is same. Use the sample standard deviation divide square n is 74.5 divided square 68. Finally, we can calculate the confidence interval is use simple mean 252.45 minus and plus T value times standard error. So we can get the answer is 234.4172 to 270.4827. So we can find that these two answers is very close. That's all. Thank you.
Now we are going to talk about question 4.5. To develop a 95% confidence interval for the population proportion of customers who use consumption vouchers to pay at the store, we can first define the sample proportion. We can note that the number of customers is 100 and the number of customers who paid with consumption voucher is 78. So we can calculate the sample proportion P equals to 78 over 100 and equals to 0.78. And then we can find the standard error. The standard error is equals to the square root of P times 1 minus P over N. And it equals to 0.78 times 1 minus 0.78 over 100. And it equals to 0.0414. And then we can determine the z-score for the 95% confidence interval. For a 95% confidence interval, the z-score is approximately 1.96. And then we can calculate the margin of error. The margin of error is z times SE, and it equals to 1.96 0.69 times 0.0414, and it equals to 0.0812. And then we can construct the confidence interval. The lower bound is P minus ME, and the upper bound is P plus ME. We can calculate that the confidence interval is between 0.6988 to 0.8612. And this is the 95% confidence interval for the population proportion paid by consumption voucher.
Okay, now we turn to the question 4.6. The question already said that the population had a standard deviation of 6 hours. So we can already have the samples, the population standard deviation equals to 6. So it told us that we need to check the Z table. Then for the 99% level of confidence, it's the 99% confidence interval. So we already had that the alpha value equals to 1 minus 99% is equal to 0.01. And the alpha over 2 equals to 0.005. Then we can need to check the corresponding Z value in the Z table. Then check the alpha over 2, the 0.005. It's just between the Z value equals to 2.57 and the 2.58. So we need to take the value between it. So we have our Z value equals to 2.575. Then the question said that the error should be less than 0.5 hour. So we have the margin of error, the ME, is less than 0.5. And also, the standard error, the SE, is equal to the standard deviation over the square root of n. So now we have the standard deviation of the population is equals to 6. So we just need to calculate the error, the n is the sample size. So it's the Z value times the standard deviation over the square root of n is less than 0.5. So we come to the calculation part. It's the 2.575 times the standard deviation over the square root of n is less than the 0.5. So we have the n value is larger than the 54.8581. So we can have the required sample size. It should be the n equals to 955.
Hi everyone, this is Wang Kaiyuan. Now let's have a look at the question 4.7. According to the question, we can know the confidence level is 90%. And the error range in this question is within 4 percentage points. As we have learned that the standard error could be estimated with this formula. Therefore, the error of the sample proportion under the certain confidence level could be estimated by the Z value multiplied by the standard error. And we put this formula into this question, we can get this one. Then we transmit it into another form, because our final task is to find the minimum required sample size. So we use this parameter to represent n. So obviously our next step will be finding the value of Z and the value of the P. To find the value of Z, the confidence level is 90%. Therefore, the alpha is 0.1, the alpha over 2 is 0.05. To check the Z table, 0.05 is here. Therefore, the Z value equals to 1.645. and to find the value of the sample proportion. In this question, we want to know the minimum n that satisfies the condition. Therefore, we need to do the maximum of this part, because there is no period information is available. So when the sample proportion equal to 0.5, it gets the maximum value, which is 0.25. And then we put these parameters into the formula. Then we can calculate that n is larger than 422.8164. So because the n must be an integer, the minimum sample size should be 423.
Hello everyone, I'm Li Zihao. Now let's look at the question 8 about the sample size for proportion. In the question, it is given that the sample proportion is equal to 30%. So here P equals to the 0.3, and we need to use a 90% confidence interval. So the alpha is equals to 1 minus 90% is 0.1. And to find the z-value, we need to find the z which corresponding to 0.1 divided by 2 is equals to 0.05. And from the z-table, we can find the 0.05 is corresponding to the z-value 1.645. And after that, from the formula for the confidence interval of proportion, we can find that the z-value times square root of p times 1 minus p divided by n, and it is less than or equal to 5%. And by substituting the values of these into the formula, we can find that the result is that n is greater than or equal to 227.3061. And since the number of people should be an integer, the smallest number of people should be 228. And finally, we can know that the necessary sample size should be 228 or above. And that's all of the question 8. Thank you for watching.
Hi everyone, my name is Zhou Yutong, and my name and student ID is shown in the file name. So now let's take a look at the question 4.9. This question is about the confidence interval for mean difference. It says a research hypothesis was that students whose parents had attained a higher level of education would on average perform better in mathematics. So now we have the first sample, which shows the mathematics test score for students whose parents are college graduates with a bachelor degree. So for this sample set, we can count that the sample size n1 is equal to 16. And for the second sample shows the mathematics test scores for students whose parents are high school graduates but not have a bachelor degree. So for this sample set, the sample size is different. That is n2 equals to 12. And assuming the population approximately normally distributed with equal variances, now we have to check the 99% confidence interval for the mean difference. To check the confidence interval for mean difference, firstly we need to calculate the we need to calculate the mean and standard deviation for both sets. That is, we already have the set 1 with n equals to 16, and we can calculate the sample mean and sample standard deviation by these two formulas, or you can just directly use your calculator. And here I use my calculator to get the sample mean for set 1 is 525.8125, and the standard deviation for the first sample set is approximately 59.801. And for the second sample set, where n2 is equals to 12, we can get the sample mean equals to 486.75, and we can get the sample standard deviation to be approximately 51.797. With these basic characteristics about both sample size, we can now come to the step 2, that is, calculate our SB, because for this question, both sample size are smaller than 30. Since N1 and N2 both smaller than 30, we're going to use the student's t distribution. So we have to calculate the SP for this confidence interval calculation. That is N1 minus 1, that is 15, times the variance of the first sample set. That is approximately 3,576.1625, and plus the second sample size minus 1, that is 11, times the second variance, that is approximately 2,682.932, and this whole calculations divided by the degree of freedom, that is 16 plus 12 minus 2, and we get the SP to be approximately 56.55. Of course, when we're going to talk about the mean difference under a certain confidence interval, we have to state clearly our assumptions. So now it comes to this is the step 2. Now it comes to the step 3. That is to say because our confidence interval is 99%, we have our alpha to be 0.01 and our degree of freedom to be 16 plus 12 minus 2, that is 26. So, we're now going to check the student T distribution table. For this table, in the row 26 and column, half of the alpha, that is 0.005. So we get the T value to be 2.779. Now we come to the last step, that is to calculate the mean difference. So the mean difference according to the formula is firstly the difference between the sample means, that is x1 minus x2 and plus or minus t, that is 2.779 times the SP we just calculated here, 56.55, and times 1 divided by N1 and 1 divided by N2. And after using our calculator, we can get this confidence interval for these two mean difference is minus 20.9544 to 99.0794, and that is our final answer. So because we are doing many approximations along the way, your answer may be a little bit different from mine, and that is okay as long as you just state clearly about your assumptions. And that's all for this question. Thank you.
So now let's get to the last question. My name is Wu Qianjie and my student ID is 2210297D. This question is to determine the confidence interval for the difference between the proportion of customers who prefer chicken at the west colon and the east colon. So first, from the form, we can get the total number of customers in west colon, N1, is 386. Also, the total number of customers in west colon, N2, is 492. And both two numbers are larger or equal than 30, so we can use the proportion difference formula here. To use this formula, we need to get some values. First is the proportion of customers who prefer chicken in west colon P1 is 0.4456. Also, the proportion of customers who prefer chicken in east colon P2 is 0.3171. To determine the 95% confidence interval, we can get the alpha as 0.05, and also the alpha over 2 is 0.025. To check the table, we can find the Z 0.025 is equal to 1.96. So finally, we use the formula to calculate the result. The confidence interval is 0.0641 to 0.1929.